University, Pak Edwin, and also Bu Lydia for making this happen. I'm joined by Bryan. He is the Developer Relations Executive for Tezos APAC, and he will be the one to conduct this workshop for everyone. Jadi, thank you for the opportunity. Paling kalau if there's any opening remarks from Pak Edwin, a word of two from you juga.
I'm thankful for Bryan and other Tezos team member for coming to this event, and we appreciate that Tezos want to actually educate the younger generation of be more savvy toward these exciting new technologies of the cryptocurrencies, and we hope that the student here will enjoy the event. And Bryan, please go ahead. Yeah.
Thank you so
sorry,
much.
Before we start, is it okay if we take a photo together? Ya, jadi boleh nggak pada buka screen-nya so we can take a photo before we start? Ya, everyone else mungkin. Okay. Ini pada malu-malu semua ya. Okay, just gonna start screen capturing. Okay, hold on. Okay. Thank you, Bryan. You can start.
Okay, thank you everybody for attending this course. I mean, they have this class, and yeah, I would like to I'd like to thank Prof. Edwin and Atalia for hosting this event as well. Yeah, so before we get started, I'm gonna just say a few words about for us. So for TZAPAC is the Tezos entity for Asia Pacific. We actually do into the adoption and the growth of the Tezos blockchain itself. And today I will be joined by Ho Chi here. So he's a student from NTU in Singapore, and he will be presenting on some parts of my content as well. So how we are going to do is he will first present his part on the introduction to blockchain technology, where he will go through you with the history of blockchain itself, what the technology actually means in the past, the present, and the future. And then after that, I will take over and we will go through, the introduction to the Tezos blockchain itself and what you can actually do on the Tezos chain, in terms of smart contracts, in terms of ecosystem, and a bit more about, like what we do here also as well in Asia Pacific for the Tezos ecosystem. Yeah. So without further ado, I would like to invite Ho Chi to conduct the class as well. Thank you.
Thank you, Bryan.
So,
let me share my screen first.
Just a reminder, like at the very end of each of our presentation, we will open up a poll to see, to check back with you guys, if the content is too hard or too easy, or it's okay, then it's a good way to feedback onto us as well, see what we can do to improve ourselves as well. So yeah, thank you.
Thanks, Bryan. So hi everyone, and welcome to TZAPAC's workshop on the introduction to blockchain. And as the title suggests, we're going to be looking at an introduction to blockchain for my part, and then afterwards, Bryan will talk to you about more on the introduction to Tezos in general. So I'm Ho Chi, a Year 2 Comp Science student at Nanyang Technological University of Singapore, NTU, and I'll be the one that's guiding you through the entirety of the introduction to blockchain part of the workshop. So at any point of the workshop, if you have any questions, you can just type out your questions in the chat. And since Bryan's still around, he'll help you answer your questions. But otherwise, we'll both visit your questions at the end of the session and answer them as much as we can. Yeah. So right, before we get into the content section, and this is just to protect myself and Bryan as well. So since we don't really go into any kind of trading later on, but I want to note that whatever I say is not financial advice, and to please do your own research before engaging in any kind of purchase or sale or any kind of other financial activity. Yeah, so do your own research. And without further ado, this is what we're going to be talking about today in the introduction part, introduction to blockchain part. So first off is on the brief history of blockchain, starting with Bitcoin. Then I'm going to explain the mechanisms behind the blockchain. And following that, I'll be sharing about some consensus mechanisms like the proof of work and the proof of stake mechanisms. And after that, we'll be looking at the blockchain trilemma, as well as some applications of blockchain technology. So first of all, on the brief history of blockchain. So blockchain and eventually Bitcoin was thought to be the brainchild of a person named Satoshi Nakamoto. And it was the first, Bitcoin was the first demonstrated use of blockchain technology, and originally intended to be just used as a peer-to-peer electronic cash system, which we now know as DeFi, or decentralized finance. And right here are some fun facts about Bitcoin. So Bitcoin was the first demonstrated use of blockchain technology, and it was originally intended to just be used as a peer-to-peer electronic cash system, and all these over here. So eventually people realized that we could do more than just finance with blockchains, and one of these people is Vitalik Buterin, and who is one of the co-founders of Ethereum. Using what we now term as smart contracts, we can automatically execute events or actions according to predefined conditions, removing the need for a middleman. So there are some links which I can go into later on, which are here. We can send the links to you all later on, but for now, just know that these are, the first one is a white paper for Bitcoin, and the second one is a documentation on Ethereum. So before we get into the more technical bits, I'll be talking about some useful background information regarding blockchain. So it'll be pretty technical and might be a little bit dry, but I'll try my best to make it at least a little bit, at least understandable for all of you. So the first one we have over here is called hashing, which is a mapping function that calculates a fixed length value that represents the original data. So hashing functions are used everywhere, and most of the websites we use, for example, the YouTube links we have this piece of data at the end, a piece of string at the end, somewhere in the URL. And for example, this YouTube link over here, the thing after the $V equals is a hash as well. So a hash is a mapping function, meaning that given one single input, it will give you the same output every time. For example, if we look at a function, we learn in math that fx equals 2x returns 2 times x for every time, for every x you put in. So for example, if you put in 2, it will return 4. If you put in like 3, it will return 6, and so on. But for cryptography, the hashing functions are much more complicated, so that they cannot be decrypted by random people out there. So some common hashing algorithms that are being used in cryptography include MDA5, SHA1, and SHA2. So Bitcoin uses the SHA256 hash function, which is under the SHA2 standard. And its output consists of 256 bits, hence SHA256. And this means that there are 2 to the power of 256 different combinations possible. Don't worry about like the names MD5, SHA1, and SHA2, because honestly, I don't really know what they are. You just have to know that they are hash functions and they produce the same output for every input. So how big is 2 to the power of 256? 2 to the power of 256 is actually in the magnitude of 10 to the power of 77. And to get something that's relatively comparable to this, we look at the number of atoms in the observable universe, which is in the range of 10 to the power of 78 to 10 to the power of 82 atoms. So we can see that it's actually really, really big, a really, really big number, and you can get so many different outputs. So we can more or less consider the output of SHA 256 to be unique for every input you put in. Yeah. So what makes a good hashing algorithm is actually that when you change the input by a little bit, the hash generated will be very, very different. And that the generated hash is irreversible, meaning that once you get the generated hash from the original value, you can't get the original value back from the generated hash. And this is what makes the blockchain very secure. So another important thing that we have to talk about when we talk about blockchains is the linked list, since vanilla blockchain is essentially a singly linked list. And what a linked list is, it's a self-referencing structure made out of nodes, and each node consists of two attributes at its core. So a node will consist of some data and a pointer to the next node over here. And that's it for the background information bit. This is all you need to know for what makes a simple blockchain. So now that we know about hashing algorithms and the linked list, what is a blockchain actually? So if we look at the structure of a blockchain over here, we can see that the image here looks a little similar to the image that we can see on this slide over here. So this is actually the structure of a simple blockchain. And the name blockchain actually is able to describe itself. It's a chain of blocks. So each block contains a batch of valid transactions, the hash of the current block, as well as the hash of the previous block. So unlike the linked list, which points to the next node, the blocks in the blockchain point to the previous node. And this is important, as we'll look at later on, because the hash from the previous block is being used to calculate the hash of the current block, together with the data that's stored in the current block as well. So this makes the blockchain immutable, as the block is derived from the information contained in the previous block in the blockchain, and tampering with a block that's before the current block will make all the blocks after it invalid. So yeah, we'll look into the hashing function of a blockchain later on. And basically the important thing to remember is that a block, the hash of a block depends on the hash value generated by the previous block, and changing the data or whatever in the previous block will invalidate everything that comes after it. Yes, okay. So here we'll continue talking about the structure of the blockchain. And right, so for the hashing algorithm that the blockchain uses, we'll talk about a generic blockchain for now. Hashing a block uses the block ID over here, the nonce, as well as the data. So each block needs to fulfill some criteria to become a valid block. And for example, if we look at our block over here, what we want to fulfill is the first 4 digits of the hash value has to be 0000. And every block on the blockchain must obey the same rules. So of course, different blockchains like Bitcoin or Ethereum have different rules compared to each other. And because of what we actually want to achieve with the blockchain, we want the data to remain the same. We want the block ID to remain the same. So all that we can change is the nonce over here. So what we want to do is actually calculate a nonce such that the combined components generates a hash that follows the rules specified by the blockchain. So the first instinct is to think that the nonce is generated like you test 0, 1, 2, 3, 4, 5 until you get a hash with 4 zeros, and that's about what's going to happen for the blockchain actually. So it'll calculate all the nonces from 0 until it reaches 1 that gives you 4 zeros for the hash. Yeah. So now for a little demo, I'll show a visual demo of like hashing the blocks and the blockchain. We won't be looking at the rest of the stuff. Yes, you can see my screen. So for the hash, if we look at the hash over here, and we type in some data into the data block. So as you can see, like without any data, the hash generated starts with E3B0C. If I type in A, it becomes CA978. And if I type in another A, this changes to a completely different hash. So you can see that just making a small change to whatever is in the data block will change the hash, make the hash completely different from what it was before. So if I for example replace A with a B, although A is close to B, it gives me a completely different hash. If I put 0 or 1, you can see that the hash generated is basically unique for whatever data we put in. And then when we look at the block, we'll just look at the blockchain. So for example, as I've mentioned, if I make changes to the data over here, everything after it is basically invalid. And if we want to make the data all correct, we have to mine starting from the first block, then the second block, and then the third block, and so on, which takes a lot of time. Yes. So right, back to the slides. So next part we're going to talk about is on centralization versus decentralization, which is the core of what blockchains try to achieve. So like in DeFi or whatever. So with centralization, we have to go to a single entity. So everything points to the middle to achieve something. And when we want to make transactions, although with all these cashless payments and all that, we don't really feel it now, but we eventually still have to go through institutions like banks or or other financial institutions. But that is not the case with blockchain, which is stored everywhere. So the core thing about blockchains is that it implements decentralized storage. So let's look at the difference between centralized systems and decentralized systems, which are on this slide. So on this slide over here. So in a centralized system, it's made up of a single server or a cluster of servers which provide service to users. While on a decentralized system, there's a large number of end nodes, and each of them are providing replicated services. So if you are if you are connected to the network, you are able to provide service to the other people. So for centralized systems, all data are stored in a centralized location. Servers are owned by a single organization. And on the other hand, for decentralized systems, we look at the data being replicated in all the end nodes. And there's a lack of a single entity that controls the whole system. So all these are actually just talking about like what we see here, that in the centralized system, everything goes to one, while in a decentralized system, everyone has that kind of a little bit of power on itself. Yeah. Right. So actually, to make the blockchain more secure, the blockchain is distributed over a large network, which means that valid blocks have to be replicated on all nodes, which is here. And what this means is that if we want to falsify any record on the blockchain, the person who wants to falsify the record would have to change all the blocks after it on every instance of the blockchain, as we've seen in the demo earlier just now.
Okay, I think it's not reflecting the right slide. Yeah, so slide 20. You're going to slide 19 or 20, is it?
Oh, sorry.
Okay, yeah.
Yeah, but no, I'm actually on the correct slide. I just wanted to give some more information on this part. Yeah. So actually further on decentralization, all the participants will have to agree on the state of the blockchain, and only when all the participants agree on the state of the blockchain will anything be able to be done on the blockchain, and we can take any actions to modify the blockchain at all. So right now, next up, we'll be talking about some of the consensus mechanisms. Actually just two, which are the proof of work and the proof of stake mechanisms, respectively. So before we go into that, we'll have to consider the question of how we can get the nodes from all over the world to agree on the same block that should be added onto the blockchain. To be able to understand this problem of getting everyone to agree on the same thing, we'll have to understand this thing called the Byzantine generals problem, and to do so, we'll be watching a video over here. Can you all hear the audio?
No.
The audio is not.
I can try to share the video first. Yeah, let me share the.
Can I just on the
video.
captions and?
I mean, it's okay. I think it should be fine. I can share the video itself. Let me just get the link. Okay.
Okay.
Okay, you guys can see the video.
I'm going to explain it by using an ancient problem that Bitcoin claims to have solved. It's called the Byzantine generals problem, and until now, it's been unsolvable. The problem goes like this. How do you make absolutely sure that multiple entities which are separated by distance are in absolute full agreement before an action is taken? In other words, how can individual parties find a way to guarantee full consensus? Here's the example. Imagine that you are a general in the Byzantine army and you're planning to attack an enemy city. You have the city surrounded by several battalions, each of them camped several miles from the other, and each of them led by another general. A coordinated attack on the city from all sides at the same time will be successful, but an uncoordinated attack will likely end in defeat. You have decided to attack at dawn, but you have no walkie-talkies or cell phones, and signals from flags, torches, or smoke could be seen by the enemy. How do you make sure with absolute certainty that all of the other generals reach consensus and all attack together at dawn? You could send messengers on horseback, but what if one of them is captured or killed before delivering the message? You would need to have a reply from each of your generals confirming that they have received your message, which means that they would have to send messengers to you on horseback, but what if they are captured or killed? What if a messenger is captured by the enemy and an imposter messenger with a fake reply is sent back to you? And how do the other generals know that the messages that they received from you are genuine and haven't been intercepted and altered by the enemy? Worse yet, what if some of the other generals are traitors and they send messages back to you confirming that they will attack at dawn when their true intention is to retreat? How can you ever be absolutely certain that all of your battalions will reach consensus and attack simultaneously? Like I said, this problem has remained unsolved for thousands of years, and at its core, it's all about individual parties being able to trust each other directly, no strings attached. Bitcoin claims to have conquered this problem. Now imagine that the battalions are actually computers on a network, and that the generals are copies of a computer program running a ledger. A ledger that, via some very complex math, records transactions and events in the exact order that they happened. The key here is that all of these ledgers are exactly the same for everyone. As soon as a change is made on one copy of a ledger, if it is proven to be true by the math, all other copies of the ledger are updated to match. What we have here is a distributed ledger that is also always in consensus. This is one of the first things to understand about Bitcoin. It is the first full consensus distributed ledger mankind has ever seen. This network can be expanded across the entire planet. It means that individual parties on opposite sides of the world can come to consensus on an event without requiring any third party as an intermediary for trust. Whether it's an order from a general to his troops or an order from you for a pizza, a distributed ledger confirms via math whether an event is true and records it permanently. Bitcoin, the first full consensus distributed ledger.
Thing that's done. Yeah. So let me just stop sharing the screen, and you can retake screen.
All right, thanks, Bryan. So in summary, what we're talking about is in the video is that each general will be representing a participant in a decentralized system, and there's no single source of truth. So each general has to maintain its own belief, and the Byzantine general's problem requires that truth be established trustlessly. So without trust, you can still ensure that everyone has the same thing on their side. And how do we do this? We do this by a consensus mechanism. So this is what they're saying. So the root problem with conventional currency is that all the trust that's required to make it work. So the central bank must be trusted not to debase the currency, but the history of fiat currencies or like our paper money is full of breaches of that trust. So problem with this, the problem is that when someone wants to modify something on the blockchain by adding a block or something, the consensus mechanism has to approve the modifications. So if everyone just decides to add his own copy, so for example, this person A adds a new block stating a transaction that he sends, he sends money to person B, and then person B makes a transaction. He records on his own blockchain that he sends some money to person A. Eventually, they will have something very different on each person's blockchain if they don't like coordinate and have this consensus mechanism to make sure that everyone's blockchain has the same information. So every end node has to modify its local copy whenever someone makes a change, and all the end nodes have to follow the consensus mechanism very strictly. So the two consensus mechanisms we'll be talking about today are proof of work (POW) and proof of stake (POS). So POW is used by Bitcoin as well as Ethereum up till around September 2022. After which it switched to the proof of stake consensus mechanism because of reasons we'll be looking at later. Yeah. So the first thing we'll be talking about is mining, which is probably a familiar term to most of you, even if you have never gone in depth into blockchains before, because of everything that's been going on in like the GPU market, the prices and shortages because of all these miners. Everything is all the GPUs are very expensive. So what mining is that it's the main way that new blocks are being added into the blockchain. So in the proof of work mechanism, what it basically means is to find a valid hash for the block. So finding a valid hash is very computationally expensive, and the condition for validation is not just 4 zeros at the start of the hash as we looked at earlier, but probably it'll be something a lot more complicated. So this condition, for example, the 4 zeros, is essentially dependent on the platform and the rules of the blockchain, and could actually change even within the same platform due to the need to manage the number of users mining, as well as the rate of block validation. So a valid hash produces proof of work, and once the nonce is found, the correct nonce is found, the block is considered signed and digitally verified, and the miner will get their reward for doing work. So that's where the work comes in. So as we can see from this graph over here, the proposed block is broadcasted to all the different nodes, and the miners securing each node will attempt to combine the nonce and the previous block header to obtain a hash number over here. Then the hash value has to be less than the target value, which is determined by mining difficulty. So just now we saw that it was 4 zeros. Now it has to be smaller than a certain number. So the lower the target value is, the more computationally difficult it gets, because there are less numbers that can be lower than the number. And if it's not true, then the nonce is incremented and we try the thing again. So like we try until we get a valid nonce that produces a hash that fulfills the target value, the requirements for the blockchain, right? Then so the thing about this is that only the first miner that is able to satisfy the inequality will get to mine the block, and the block rewards are distributed to the miners. So this is why the more powerful the computing resources are, the higher the chance that the miner will be the first to win. And some argue that this is not essentially fair, because the power and control still goes to the rich, who are able to afford like better GPUs, better mining resources, and better computing resources and all that. So this is a lot of data, so I'll leave this over here for a while for you all to take it in, and you can just ask questions if you need to in the chat. We'll answer them later at the end of the session. Okay, it's basically a flow chart that shows you how you want to generate the hash, recalculate it, and the process is repetitive until you get the correct hash that works. So to get your blocks approved and added into the blockchain, we need a mechanism that does not involve a central party. So we use this is a consensus mechanism. That's what the consensus mechanism is for. So when a new block wants to be added into the blockchain, the network will query the blocks on the network. So if 50% or more of the blocks find that the new block is legitimate, it is approved by majority voting. But so this is like democracy in a way. You vote for the block you want to be added to the blockchain. But as we will explore later, this is not 100% safe, although it's actually pretty good. Especially for smaller blockchains, it's not 100% safe. So Another thing that makes the blockchain very good is the immutability, because whatever you stored in the blockchain remains there, and people cannot just change it to whatever they want. So as we've talked about earlier, to add a new block, use the data. To add a new block, we'll use the data nonce and the previous block's hash to generate the current block's hash. But the difference is, if we want to change data from a block that's right in the middle of the blockchain, so there's a lot of other stuff to the left and to the right, its hash will change when we change the data, and all blocks after it will have the previous block's hash changed as well. So their own hashes are no longer valid, and we'll have to find a new nonce for every single block that came after it. So for a normal blockchain, blocks will continuously be added into the blockchain. So even if we manage to change, even if we are a little bit faster than new blocks are getting added in, we'll still be pretty behind and not be able to catch up to the new blocks, and it might take forever to update the block's hashes. So this is what makes the blockchain history basically immutable in a sense, or rather extremely difficult to be altered. Additionally, the owners of all subsequent blocks will have to agree to remining the blocks if any changes have to be made. So in essence, the difference is finding a solution to one problem, which is finding the nonce for one block, compared to finding a solution to many consecutive puzzles in the blockchain. So yes, so as we mentioned, it's extremely computationally expensive to alter a block, which discourages the changing of data in a block after it's been added to the blockchain. So in essence, for mining, it's a competition where if you're not coming in first, you will have wasted your efforts. So if 1 million people compete for the nonce of a single block, only one person will actually get the nonce, and all of the other people will have wasted their efforts. So like, even if you put in a lot of computational power to calculate nonce, if you don't get the correct one, it's all wasted. So why are people still doing mining actually? If this is the case, only one person gets the rewards. So first of all, the mining rewards is quite big, and second of all, there are these things called mining pools, which we won't really be talking about, where people come together to pool all their computational powers such that like each person in the mining pool will be at least guaranteed partial profit based on how much they contribute. So it's like a group kind of system where people collaborate to share the rewards, so that they will be guaranteed to at least get part of the reward based on the computational power they provide. Right, so to summarize on the proof of work consensus mechanism, a trusted third party is unnecessary. The hashes allow us to check the validity of the block, and the proof of work consensus mechanism is what makes the blockchain immutable. Right, so next we'll be looking at the proof of stake mechanism. So some blockchains that use the proof of stake mechanism is Tezos and Cardano, as well as Ethereum after September 2022. And one of the reasons behind that is because for the proof of stake consensus mechanism, there is no competition in mining, and users deposit a certain amount of stake, and an algorithm chooses the users to become validators. So if you put a higher amount of stake, you will have a higher chance of being selected as a validator. So as a validator, you will have to, your responsibilities are basically to order new transactions and add new blocks to the blockchain. So the difference is that here, there's a chance of people being validators and they do things to their own benefit. So what happens is, if you do something, that's where the stake comes in. So if you do something that's not beneficial for the blockchain after you're chosen as a validator, you'll lose all your stake, right? So if you put in this amount, you'll lose this amount if you do something wrong. And after the transaction, the validators will be rewarded for their work in validating the transactions and blocks. And basically that's it for how the proof of stake works. So it's not that much compared to when we talked about proof of work. So comparing proof of work and proof of stake, we can see in this table that there are some big main differences. So for the recipient of the reward is given to the fastest miner, so it's a competition. While for proof of stake, it's given to validators, which is chosen before the solving of the thing starts. So like, let's say for the million people argument that I mentioned earlier, 999,000 people will have wasted their efforts for the proof of work mechanism, but for the proof of stake mechanism, only the person chosen will be working. So a lot of things, a lot of computing resources is saved. For the nature of the reward, it's emitted by the protocol, the blockchain, once a block is solved. While for the proof of stake, is basically working as a fee system. The network pays you for your work. And for its robustness, proof of work, because it's used in blockchains like Bitcoin, Ethereum in the past, it's older and more well-tested and used in many blockchain projects. While for proof of stake mechanism, it's relatively newer. I wouldn't say it's that new anymore, and less well developed, but there's potential to be faster and more efficient than these proof of work systems like Bitcoin. So for the security and scalability, the proof of work is completely decentralized and more secure, while the proof of stake is faster and has a lower energy consumption. So we'll look at this. We'll continue to look at this later on. There's a part which we'll talk about regarding the dilemma of decentralization, energy consumption, and whatever. But for in terms of the pros and cons, here are some of the differences between the proof of work and proof of stake. If we look at the proof of work mechanism, it's more secure, its network is open and decentralized, it's scalable, and the users, for those who successfully manage to solve the computational problem, they'll earn greater rewards. While for the proof of stake, it's better because the transactions are faster, there's a guaranteed reward on validation, and it's less environmentally detrimental. And for the cons, high energy consumption, slow mining, and high GPU prices. While for proof of stake, it's newer and there's less people adopting it, as well as it being lacking in proof of scalability and security. So here are some examples of proof of work blockchains compared to proof of stake blockchains. And yes, so this is the dilemma or trilemma that we'll be looking at right now. So should there be a break here somewhere? Because there's quite a lot of information previously. I think
yeah, I
can
think
have,
that let's take like a 3 to 3 minutes break. I'm just going to open a poll first. See how see if the content is too hard as well or too easy, or is it okay? Is it okay for you guys to understand? Just going to launch it now while we take a short break just for 5 minutes. Yeah. So you can participate in the poll as well. Any questions from the room here? Like, you want to ask the question, you can always unmute on yourself. And yeah, from the poll now, you can see that most of you find that like the content is quite okay on both parts, the consensus mechanism as well as the blockchain. So I think a bit more people actually said that the consensus mechanism content is slightly harder. So yeah, if you want to ask a question now, you can always feel free to unmute on yourself and ask on that question as well. Or you can type it on the chat as well if you don't want to unmute on. Yeah.
Okay, it's around 4:50 now. I'll be continuing. Like, looks like most of you think that it's hard to kind of understand what the use cases of blockchain might be, which we'll be talking about later on actually. So hopefully the examples that I'll be going through will give you a better idea of how a blockchain can actually be used later on. So right now we'll be looking at the blockchain trilemma, which refers to the three things that we want to achieve with a blockchain, which are, as I've mentioned just now, we want to balance decentralization, security, and scalability. So the ideal situation is that we have really good scalability, really good security, and maximum decentralization, but in the real world, this is basically not possible at all. And you can see that the different consensus mechanisms give you basically different benefits. So proof of work gives you more decentralization. Proof of stake is slightly more balanced, while PODC, which I'm not really sure what it is better than proof of stake. It's pretty new, so I think it came out in 2019, if I'm not wrong. So these are the blockchains that focus more on the decentralization and security. These are the blockchains that focus more on security and scalability, and these are the blockchains that focus more on these two parts of the trilemma. So before I move on, I use the terms decentralization, security, and scalability, but actually what decentralization means is to create a blockchain system that does not rely on a central point of control, as we've discussed earlier. And for scalability, I don't think we've talked about it just now, but it's basically the ability for a blockchain system to handle increasingly growing amount of transactions, because for some blockchains, if there's a lot of transactions, it will take very long to validate and add a new transaction to the blockchain. Then security is the ability of the blockchain system to operate as expected, to defend itself from attacks, bugs, and other unforeseen issues. So when we talk about blockchains, I'm not sure if you all have heard of it, but like there have been quite a few attacks on blockchains. People have been stealing millions or something, and I think quite a lot of people are pretty afraid. But yeah, so there's an issue that blockchains face, and we have to try to strike a balance between these 3 points when we try to create look at the blockchain that we want. So the next part we'll be talking about is the POW attacks that we should know about and take notice of. So this is specific to the proof of work, a consensus mechanism, and it's called the 51% attack or the Sybil attack. And what this happens is when a miner or mining pool controls 51% of the computational power of the network, or just more than 50% of the computational power of the network, it can create fraudulent blocks of transactions for themselves while invalidating the transactions of all the other people in the network. So normally what will happen is that these fraudulent blocks, or basically illegal blocks, which will be detected and rejected by the network's users. Since generally more than 50% of the users do not agree with the new blocks that are trying to be added in. But with more than 51% of the computational power of the network, the attacking party can basically insert fraudulent blocks since they hold a majority of the computing power. And with only 49% of the remaining computing power, the other parties will be overpowered and cannot reject the change made by the block. So a specific example of this is in this thing called double spending, where the attacker sends a transaction, and since it has more than 51% of the computing power, it can just reverse the transaction, making it appear as though as they had the currency that they had just spent. And this is only possible because they have the majority of the computing power. So this is this will be more of a problem in smaller blockchain networks. So for blockchains like Bitcoin, they are just so big that one person or one party can basically never get that much Bitcoin in their hands. So the next one is selfish mining, which occurs when a selfish miner or a group of selfish miners solves the hash, but instead of telling everyone on the network that a new block has been found, they withhold this information, keeping it private. So while the other people are mining on say this chain, they will continue mining on a separate one and mine more than the normal people on the public blockchain. Then they will release the private chain to discredit any new blocks that are going to be published on the public blockchain. So for example, in this slide over here, we look at the white ones as the public one, and then the gray ones as the private ones. So the normal people will mine all this this block over here, but it will just get cancelled out completely because the total power of the private chain has is more than that of the normal one. And this only works because people group up together and join forces to hide their generated blocks from the blockchain. So in a sense, it's kind of similar to the 51%, but the way it functions is different because it just deviates from the normal over here. So as a result, the people mining on the private chain can claim more cryptocurrency than the people on the public chain. And yeah, it only works when there's a cartel of miners being formed, which act in unison to increase their profits, as well as the influence they have on the network. And finally, we have the DDoS attacks, which is not unique to blockchains. There are DDoS attacks in like things like games as well, where a malicious attacker can send a large volume of fake requests to some node. What this does is that that specific node that they're attacking, all the nodes processing resources, basically, essentially all of the nodes processing resources will be consumed. And this disrupts normal computations and blocks normal traffic to the server. The legitimate transactions will be blocked from being added to the blockchain. And then the attacker is basically able to add new nodes to the network based on the 51% model again. So as we can see, the main problem of the POW consensus mechanism is the majority voting system. So in essence, the impact of the DDoS attacks is that you stop people from voting, and then because that many people don't vote, you will have the majority of the votes. So this is actually, DDoS is actually extremely illegal, and someone who does a DDoS attack on a public server or whatever can go to prison for it. So on to the proof of stake attacks, which are a little bit more unique than the proof of work attacks. So the first one is the nothing at stake attack, and it's the first of the POS attacks we're going to talk about. There's two. So the nothing of stake attack requires you to know what a fork is, and a temporary fork basically occurs when two competing blocks are simultaneously proposed to be added onto the blockchain, or when there's some other activity happening at the same time. So the fork is resolved when majority of the people works on one side of the fork. So for example, in this situation, this block, these two blocks are proposed at the same time. So it will split up over here. But since more people work on the blue block over here, this will become the main block that's being continued on, and the red one will be rejected. So this is what is supposed to happen for a normal when a fork happens normally. So miners will have to put their stake on the fork to vote on which one is correct. But the problem is when people stake their resources, if the thing gets rejected, they're basically going to get the stake back, because this is to encourage people to actually vote on the fork. So you basically lose nothing by signing each and every fork whenever it's generated. So for example, in this case, a person who actually knows what they're doing will basically vote on every single fork, so that they will be able to guarantee that they get the benefit, no matter which fork is chosen, right? So since there's no cost, mining both does not matter to a person's bottom line. So the counter argument is that if one person only mines on the rejected block and mines all the way up, and then the other one is the one that's being chosen, this guy will basically lose all. He won't lose his resources, but he'll lose his time in trying to mine on the rejected fork. So in other words, mining all of the forks that's generated ensures that the miner will get their reward no matter which fork wins. And the problem with this is that since everyone ideally for their own profit votes on every single fork, it's very difficult to reach a consensus on which one is correct, since everyone just votes on everything. Yeah, so the next one is the stake grinding attack, which is a class of attacks where a validator performs some computation or takes some other step to bias the randomness in their own favor. So how this works is actually because proof of stake uses some random number generator to choose its validators, but in general, most of the randomness, computational randomness, is not truly random and instead depends on a certain seed to get this random number. So a person who is smart enough will be able to use this seed to predict what the random number will be, which defeats the purpose of the random number generator. And because they are able to predict the random number, they'll be able to modify their own block header such that the random number generator algorithm will choose their block. So this is basically it's not a problem to the blockchain, but it's a problem in terms of the fairness it provides to the people who stake their resources on the blockchain. Right. And finally, the last part of my my part, and which I promised to talk about after the poll, is on the use cases of blockchain. So the first and most important feature of the blockchain, which it was originally created for, is in decentralized finance. So decentralized finance, or DeFi, allows people to hold money in alternate forms, such as cryptocurrency. And with DeFi, people do not have to go through intermediaries, such as brokerages, banks, or exchanges for their financial services. And financial products and services will be readily accessible to anyone with an internet connection. We've actually talked about this quite a bit just now, so I won't really go a lot in depth into this, because to talk more about this is an entire new topic on its own. So the next use case is on NFTs, which are another use case you might have heard of as well, like the NFT hype and the prices going so high and all that. So what the NFT is that it's a non-interchangeable unit of data stored on a blockchain. So what separates them from fungible tokens is that they do not have a definite value assigned to it. So what this means is when we talk about cryptocurrency, one Bitcoin, for example, I own a Bitcoin and someone else owns a Bitcoin. The value of my Bitcoin and the value of the other person's Bitcoin is exactly the same. But on the other hand, every NFT is more or less unique. And even if this NFT has the same exact same image or JPEG or whatever that's associated with it, its value can come from other things like who has owned it before, whether who has owned it before, what kind of features it grants you, the access kind of things. And there's a lot of different things, like for example, for this monkey over here, stuff like his hat, his sunglasses, his earring can change the price of the NFT by a lot. So every NFT is more or less unique, and if you trade one for the other, even if the JPEG is the same, you basically don't have the same thing anymore. So the other thing that people complain about is right, I can just right click save image as, and I'll basically have the NFT, right? But yes, the most NFTs are downloadable. They come in the form of PNGs or JPEGs or whatever, and anyone can hold on to it. But only the person who paid for it can claim ownership. And that's the difference between owning the image and owning the NFT. The transaction to buy the NFT is baked onto the blockchain at some point, and you can claim a copy of the NFT, but if the digital signature on the block does not match yours, then yeah, you own the image on your computer, but you don't own the NFT. So for people like artists, NFTs allow them to remove the need for agents and middlemen and connect them directly to their audiences. So a parallel to this is, like, for example, artwork we can see in the museum. Like, for example, when we look at an artwork that's in a museum, people can just take photos of it, right? they can take out their cameras, they can take out their phones to take photos of the Mona Lisa or whatever. But their photos will still not have the same value as the original art piece that's being just in the museum, right? So that's the difference between like owning images of the NFT and owning the NFT itself. So another thing that NFTs are being used for are as keys that allows its owner access to communities, experiences, or goods in both the digital and physical world. So yeah, so if you own like the image of the NFT, you are basically you still won't be given access to things like these communities or experiences, since you are not the owner of the original NFT. So that's one of the ways where NFT gains its value. So another thing that blockchains can be used for is in electronic voting. So in a centralized system, a hacker simply has to hack the database and manipulate its results. Not saying that it's easy, but there's just one thing that the hacker has to access to get total control of the results, right? But when we're talking about in decentralization in the blockchain, every single vote is recorded on the blockchain and has to be approved by a network. So if the hacker tries to change the data on like one of the nodes, for example, all the other nodes will basically be able to disagree with it and invalidate this change. So this makes it virtually impossible to hack electronic voting system that's based on the blockchain. So I guess lastly, decentralized applications are another use case which is quite popular nowadays. And with so many people having knowledge on software engineering, this is a field that a lot of people can potentially go into, even if they have no idea about anything related to blockchains. So as long as you have information, as long as you know how to create websites, you know how to access APIs, there's this Web3 library which allows you to connect your app to the Ethereum blockchain or whatever blockchain networks that's out there. So what decentralized applications are is that there are digital applications or programs that exist and run on a blockchain. And because of this, they are free from the control of a single authority. Right. So a benefit of this is that, for example, if we're talking about developing on a centralized server like AWS or Azure or Google or whatever, these servers can still go down. But when we talk about decentralized server, when one of the nodes go down, we still have other nodes to rely on and get information from. And this works in a similar way to a peer-to-peer network. So this encourages direct connection between users rather than through a central organization like here. And there's resistance to censorship and being controlled by a single entity. So there is better privacy. So there's a problem though in terms of scalability, because when there's a large amount of data moving about, every node will have to continuously update the data that's being transferred. So for example, if I play a game or something and I constantly gain resources, when I update the resources onto the server, all the nodes will have to update the same resources on their server, and this will basically overload everyone's computer, which are not really designed to handle this many updates compared to a centralized server like in AWS or whatever, which is specifically designed to handle all these kind of data. right? So yeah, so one of the decentralized applications that could be made and is used in a lot of demonstrations or Web3 guides is Kickstarter clone. And for me, honestly, this was the thing that convinced me that the apps might be useful. A Kickstarter clone. So if you've never heard of it, Kickstarter is a place where people fund a project in hopes that the project will succeed and they'll get early access and to promote people to continue development, to promote development in small communities. So the main problem with Kickstarter is the trust issue, because sometimes developers are not really good people. They'll take the money that people have funded the project with, they run away with the money and without giving a legitimate product in the end. And then the funders are not able to reach these developers, right? So one thing that can solve this is a decentralized application. If we look at a blockchain-based decentralized application, we use these things called smart contracts, which you don't really need to know about yet. But what this ensures is that the funds can be transferred to a third party, essentially the developers, only with the approval of its backers. So like all the people who are funding the project will get to vote on whether they'll allow the developer to take out the money to use it for purchase. So for example, if the developer decides to take this money and send it to their bank, his own bank account, all the backers can basically veto and say that no, you can't say that no, you can't take the money and put it into your bank account, right? So the backers can vote to stop the transfer of money, which is an extremely useful use case for a product which hopefully is able to promote the idea of creating new stuff, development, innovation, and all this. And I believe that this has a place in the DApp field. Yeah. So I'm sorry, I said that the previous one was the last one, but there's still one more portion. So this will be quite short. So there are some problems faced by blockchains. And first of which is the extremely high energy consumption to solve complex mathematical problems in the proof of work blockchains. Yes, and that's it. That's a big problem in the blockchain world, especially for the proof of work consensus mechanism. And next is the difficulty to integrate blockchains into organizations, because making changes in organizations is extremely expensive. Companies don't want to rehaul their whole infrastructure just to support blockchains. And we can see that currently most of the users on blockchains are individuals, and despite a lot of interest of people getting into blockchains, the big organizations will find it very costly to move away from decentralized systems. And last of all, the transactional speeds of blockchains are very different, and even within the same blockchain, because of when the number of users increase, the speed at which processing of the transaction takes place will slow down, because more things go into server slower, and yeah. So this may result in a lot of transaction fees, and because of the huge transaction fees, the blockchain may be less attractive to a lot of users. So if there is actually a widespread adoption of blockchain technology, this will become an even bigger problem, because more people will be injecting and taking out from the blockchain at any point of time. So yeah, thanks. That's it for my part. Please stay. Bryan still has his content to present. I hope you enjoyed my presentation, or at least learned something from it. And if you have any questions, you can continue to ask in the chat. We'll try to answer as best as we can. Yes. Thank you.
Yeah, so let's take a short 3 to 4 minute break in, and like I'm gonna relaunch the poll to also see like what's the what's the response like for each of the portion as well, because I can understand that it's more, I mean, it's as well as we want to want to go through what the blockchain technology actually means in one sense, to actually to understand from the start to the very end, and the different consensus mechanism that is actually used in in Bitcoin, Ethereum, and Tezos itself. So it means that you get an overview, or like a bit more about what this whole technology means, as well as the use cases, what you can do with it. And yeah, before I proceed on to the next one, would I just like you to do like the poll as well? Yeah. Yeah, okay, I think I'm going to start soon. So I'm just going to share on my screen. And to introduce you a bit more towards the Tezos blockchain itself, you guys can see on my slides, right? Yes, okay, good. Yeah, so a bit more about for us, for what is on the Tezos, you can just take a look at this video first. I will go through a bit more what we are in terms of our consensus mechanism, how we work, our governance, our how we actually stake, because we are actually a proof of stake, a blockchain, and not a proof of work, a blockchain, as what for Ho Chi had actually said in the past. Yeah, so just going to play this short video about us.
What is Tezos? Tezos is a blockchain designed to address, among other things, the problems of scalability and governance faced by public blockchain networks. Tezos' design allows for seamless upgradability through its on-chain governance mechanism. The Tezos community can build and use decentralized applications, dApps, on the Tezos blockchain. They can also participate in the governance of the Tezos ecosystem by submitting and voting on proposals. When approved, proposals are executed and implemented automatically. This mechanism allows Tezos to evolve quickly, adopting the latest technological innovations without ever needing to split or hard fork the network. Tez, or XTZ, is Tezos' native cryptocurrency. Tez holders have access to voting rights and staking, which yields staking rewards. Apart from its community-driven on-chain governance and flexible design, there are other important features of Tezos worth knowing. Tezos uses a unique liquid proof-of-stake consensus mechanism. Users can delegate their Tez tokens to validators, known as bakers, to receive rewards. Tezos users can freely switch between bakers in order to support one that is in line with their interests. This is especially important when it's time for voting on proposals. Tezos is highly decentralized. It has a global network of thousands of nodes and hundreds of validators. The majority of network nodes consist of bakers or delegators, meaning that there is a great portion of Tezos tokens locked at stake. Tezos' decentralization is one of the key factors that make the network reliable and highly secure. Also, its open source code is open for anyone to check, and all developers are welcome to contribute. The Tezos ecosystem is growing rapidly, with an increasing number of dApps and development tools. With the rising popularity of NFTs and DeFi, artists, users, and developers are choosing Tezos for its low transaction fees, strong community, and high security. For instance, NFT artists are using Tezos-powered marketplaces to mint, share, and sell their art, without the need for costly intermediaries or agencies. Tezos also has an increasing number of blockchain gaming and entertainment projects, and these are just a few use cases. The Tezos ecosystem has several tools developed by its community that can support all kinds of users, builders, and validators. This allows the Tezos community to grow larger and become even more decentralized and secure. Visit Binance.
Oops, let me just, okay. Yeah, so yeah, you can see on my slides, right? I'm not sure if I click on the wrong thing. Okay, yeah, so a bit more about for Tezos and its history. So our founders is Arthur, a bright man, and his wife, and they actually launched their white paper in 2014, and we had actually our mainnet launch in 2018. So we've been around since close to 5 years ago, since the September of 2018. At the time, we were the largest ICO at the time. So ICO is an initial coin offering where investors at the time or venture have capitalists actually fund coins around. At that point in time, that there's a lot more. Like there was also a list of cryptocurrencies like a Ripple and various other coins around, and we actually surpassed like for Filecoin's 257 million token sale at the point of time. So and why are we for special? So what are the main distinguishers or key features that that we did distinguish ourselves from other have blockchains? So there are many other have blockchains. There are Bitcoin, there is Ethereum, there is a Ripple, there is all kinds of blockchain around, and like the main three features would be, the first one will be we have this thing called protocol self-amendment, where we actually do on-chain voting to actually do our own self-amend our protocol to make our protocol in a better stage. So that's the one part. And then the next part is actually like the smart contract formal verification. So our smart contracts are I trying to use a bit more towards a formal verification, which is more towards a mathematically complex way to make sure our smart contracts are secure as well. And the third part will actually be our liquid proof of stake consensus mechanism, where if you actually for previously when Ho-Chi was actually presenting on the proof of stake, there are many proof of stake kind of consensus have blockchain around. So there's a lot more than that. And we actually use this thing called the liquid proof of stake consensus algorithm itself. So to give you a bit more about the Tezos ecosystem, the governance, the voting and grants as well, we do in such a way that we allow like a digital community with the Tezos users, where we actually reduce the likelihood of a hard fork. So if you know about what for Ho-Chi has said in his previous presentation, a hard fork would mean that there are different communities that belong to a fork, and if one big community don't agree to your way of to your way of your consensus, they can always do a hard fork, which is split up with the blockchain itself. So one example of a hard fork is Ethereum and Ethereum Classic. So Ethereum and Ethereum Classic are, if I'm not wrong, Ethereum Classic is actually a hard fork out of Ethereum itself. And at that point of time, it was because due to some disagreement to how the protocol actually works, then they decide to hard fork. So for us, we will want to reduce this kind of disagreement or discontent in our own Tezos ecosystem itself. And this is how we actually do it out, where our on-chain mechanism actually does it in such a way that we do our voting in 5 different hash periods. So each of the chain or each of the blockchain itself, they have their own way of doing things, where you have to submit up to for proposals to amend on your protocol itself. So this is like the proposal on the period, what you want to change to on your blockchain itself. There will be have people or the users of the blockchain itself would want to do that to see what they can do to improve or change the way on the blockchain is actually trying to function. And then after that, there's actually an exploration stage where the bakers, so the bakers in this case is called the stakers. So the stakers are people who own a share of the cryptocurrency, who own a share of a certain amount of cryptocurrency in the Tezos chain itself, and they do have some kind of voting kind of power to vote to test out which is the best proposal to make our blockchain it's better, it's more secure, whatever the reason it might be. So that's going to be the exploration stage, and then there's always going to be a cooldown to let time, it's like more like a cooldown stage to let time pass. And then once it's up for promotion, then we can actually test it out and bring it on to the mainnet, where then like the stakers or the bakers here will actually implement this new infrastructure for the new upgrade itself. So now we come on to the history of the Tezos on the upgrade itself. We've been doing like at least 13 upgrades for so far. If I'm not wrong, the next upgrade should be in a few months' time, where so what does this upgrade means or does to the blockchain itself is to make sure that we scale our blockchain, make things transaction is faster. If you want to add in a new kind of infrastructure to the blockchain itself, it does help us to upgrade our blockchain along the way as compared to onto Bitcoin, where it's still in in Bitcoin's comparison, it's a proof of work kind of a blockchain where it still stays on the same, where you can't scale things up. It's very fast, and it takes a long time for for the first on the blockchain, which is it's for Bitcoin to actually scale things up, because they are like still in a bit of a very ancient state, I would say lah. So this is what a lot of some of the new chains around that are doing as well. They want to do this as well. They also want to upgrade on their chain to make sure that their blockchain itself can support a higher amount of transactions and more have benefits and features like that. And yeah, I think I already explained, and me and Ho Chi already explained about the forks itself. So a bit more about what are the different forks around, and what is the Tezos on-chain like the government means for us. It's like a soft fork, in a way, I mean like a hard fork is a way that it's like what I said, two different communities has a split of what they want the chain to be. So it's like saying that this is a group of people that say that, oh, I do not want to go on to this agreement that I want to upgrade to this kind of a version. So they would disagree, and they will actually leave it. They will fork it out from the original chain, and they will move on to their new chain. And what on the Tezos on-chain on the government means that is that we do not allow this to happen. So we actually preserve our currency in one sense, means that you do not have different currencies. So it's why you see Ethereum and Ethereum have classic. These two are different, have currencies as well. And with this, and what it means for us is that it helps us to make sure that we don't split up the community as well. So a bit more about the liquid proof of stake as well. What is baking is almost the same purpose as staking, where you hold some coins that allows you to stake or hold to vote to validate blocks and to get rewards based on how much your stake coins are. So it allows you to participate in the network itself. Means that you have a chance to vote, to send proposals, to pass proposals, to amend proposals and things like that. So it helps you to be part of the chain itself and make sure that you have a say in the chain. So what it does is that when you are a baker or staker, you delegate some of your rights to a staker. If you don't want to, let's say if you don't want to be a baker, you can be a like a dedicator where you can send in your rights to another person to do it for you. And this allows you to participate in the network itself to receive rewards without trying to maintain a node. So if you're a staker, you need to build it's like your own node. You need to set up your own computer to manage on your own node, which is not what everybody wants. So what a lot of people do is that they have some coins around, they send to these guys who are maintaining the node, and to make sure they also get a amount for maintaining to help to maintain the node as well. Yeah. And yeah, and then most of the tokens will also, there's a minimum time for you to lock out as well, where you need, in order to make sure that you do not just use your coins here and there, because this is for the purpose of voting and allowing the amendment to pass through. So once the amendment has passed through, then that amount of time that you need to lock up will be free already. So it means that once this amount of time has passed, then you can use back on your coins that you already have staked to do whatever you want to, let's say vote or amend for the protocol or for the proposals and things like that. Yeah. So this is a diagram of what Tezos APAC is, where some of the people will actually would want to delegate some of their coins to someone else, that they will have to maintain on the blockchain itself. And then after, on that point of time, they will get a reward based on after they have verified and validate on the block, which is when you verify and validate on the block, is trying to make sure that the security of the blockchain is intact, and to make sure that you as well as create a new block, which is a new block can be part of a new block will always consist of a transaction where it makes sure that things are going to be in consensus on the blockchain itself, where like the data will always be the same for on everybody's ledger in this instant. Yeah. Okay, so then I would compare to the different proof of stake consensus mechanism. So there's actually a lot more other proof of stake consensus mechanism as well. So I believe that for DPoS is the delegated proof of stake. Us is under the liquid proof of stake. So it's as you can see by the acronym. So there's a lot more than that, and each when you see through each of the different chains itself, they all have different ways of how they want to boot things around. How do their stakers maintain on the blockchain? How are their validators? What is the law or the rule of law for their own chain, or how the validators are supposed to to maintain on the block. So as you can see, some of these are the differences that they all have, and it depends on each of each of the proof of stake of the variance of the proof of stake. So yeah, you can see through some of these examples, and they're not always going to be the same, I would say, because each of them have their own kind of law and their own rules as well. Yeah. Okay. Then so I already said about what is on the, so how does the Tezos chain work? What is the proof of stake mechanism for the Tezos chain itself? Now I want to move on to smart contracts on Tezos itself. So before I move on to smart contracts, what is a smart contract? A smart contract is actually a piece of programmable, executable piece of computer code that is on the blockchain itself, that you can use to dictate the terms and the condition and agreement between the different parties on themselves. And so not all blockchains have smart contracts. Bitcoin don't have a don't have this kind of a feature. Ethereum has, and if I'm not wrong, Ethereum was the first chain around that actually did the smart contracts. Then after that, the rest of most of the rest of the other chains and other coins also have a smart contract as a feature as well. So and why are these important? Why is this smart contract so important? is that they allow us to have trustless programmable execution. It means that, you know, it's like it's like a agreement where you want to buy, let's just say you go to the supermarket and you want to buy, you know, like an item from the supermarket, and in the future, if you can write out code, it will be all dictated by code and agreed by code that, you know, you cannot change on the contract itself, and you cannot steal on the contract. It will always be in a way fixed to that limitation that, you know, if I have wrote down a smart contract, it will only execute based on the terms of what the agreement was. Yeah. So this is why smart contracts are very useful. It's because it will enforce wherever the terms and conditions of the agreement is. So means you can't change the agreement itself. Yeah. Or it kind of reduces the need or you know, like the ability to commit fraud as well. Yeah. Okay, so then I move on to what is the Tezos smart contract based on. So the Tezos smart contract is based on the Michelson low level language. So it's basically a stack-based language code that is like it's like a, you know, it's if you ever play with microcontrollers and things like that, you might be familiar with this kind of operations that it's a very low level language that allows you to test and to run your smart contract, but it's a very hard way to do things. So one way how we wanted to improve on it is that we do have a high level language. This thing is called Lego, where you have 3 different syntaxes of Lego. If I'm not wrong, one is Python, one is Camel, one is TypeScript. So it allows you to write your code in TypeScript, in Python as well, and then this is like a IDE that helps you to convert this code into the Microsoft code, and then it allows you to run the smart contracts based on what kind of code you have written down as well. So it allows you to deploy on the Tezos chain as well. So this is just one of them. There's actually another one called for SmartPy. So for SmartPy, it's a high level like a library that uses the Python framework. So means that you can use, if you know a bit more towards the Python language, you can use that to use your knowledge of the Python language to write out your smart contract in SmartPy, and then it allows you to convert this code into the Michelson code and deploy a smart contract from here. So this helps us to make sure that, you know, because not everybody understands what is Michelson, but a lot of people understand what is Python, what is TypeScript, what is JavaScript, and various forms of programming languages itself. So this actually helps us to, you know, to onboard like have people that you know, like who are very used to Python and for them to efficiently write down smart contracts with Tezos itself. So a bit more how it should look like is that, you know, on the left side, it will be this is the legal IDE, where you can actually I can always send you on the website. So you can actually go to the legal website, and then you can write down a smart contract here, where and then you can actually deploy it there. They do have like examples of how to write a contract, how to write a simple like a contract. It can be a calculator, it can be, you know, it can be things like you know, a math kind of a function that you want to implement. So things like as simple as that, it can be done, or as well as more for various things like, oh, you want to do a NFT, you want to deploy a NFT kind of a contract to make sure there are different properties of an NFT. So there are templates around on both of these websites, so the legal and the Smart Pi IDE itself, they do allow you to directly deploy a smart contract on the Tezos chain itself. Maybe afterwards I give a demonstration, then it's a bit easier to understand what I'm trying to say. Yeah. So I just do a demonstration at the very end. Yeah. Okay. So so then you come on to the scalability part, which is what are the different scalability issues that a blockchain face. So a blockchain face a lot of issues, like what Ho-Chi has said, what are the problems of blockchain? Is energy, it's not energy efficient, the transaction speed are not so high. So how do we want to solve all this in a blockchain? Is that we do break down into two parts. So the first part will be the layer 1. So the layer 1 is your framework for the blockchain itself. What I mean by framework is that you have on the Tezos on the blockchain. That's really your layer 1 itself. That's like your base layer itself. So that's a layer 1 where things are being built there. We improve it there. We send amendment, have protocols to improve the layer 1 itself. That's the base, that's the base layer. So when we come on to another layer, which is the layer 2, a layer 2 is actually built on the layer 1 itself. It means that it's actually a different, like a solution that you can use to to make things more faster, make things more private, make things more secure. So a lot of these examples of a layer 2, it's a roll up, it's a roll up, it's a state it's a state channel, and as well as if you ever heard about this thing, I think it's mostly on Ethereum, is on ZK on ZK proofs. So there's a few of these layer 2 solutions that actually help to solve this kind of transaction speeds and all of the slow speed of the blockchain itself. Yeah, so so this is what I was trying to say, where there's a layer 1 where you have all your Bitcoin, Ethereum, and Tezos. That's your layer 1, and then your layer 2 is going to be kind of like a solution on top of it. So yeah, so then I'll go on a bit more, but I won't really explain too much about a layer 2 because it's a very in-depth thing. It will be a very it's a very in-depth kind of technology where you do have to research a lot on that, and a lot of these examples are like are being done mostly on payment on channels, where it helps you to do some of the faster payment transaction speed. So let's just say for Bitcoin, it will be the Lightning protocol itself, where they actually do a smart contract to send to a different payment channel to actually do all your transactions in that payment channel itself. And then you also have privacy technologies such as the ZK, a zero proof, to make sure that it's all done by computational and math, by in one sense that all the transactions are done by math and science as well, and then it allows you to make sure that these are kept in a private way. But like what I say, these are pretty in-depth kind of technology. So if you're interested, you can always search online for this kind of tech. There's a lot of solutions being done on different kind of technology as well. Yeah. Okay. So then I go on to the Tezos ecosystem. So okay, what would you expect of of a cryptocurrency ecosystem itself? Is that first thing, we obviously have all the crypto exchanges. These are centralized exchanges. That are like some examples that I won't name all of them, but these are some of the examples of crypto exchanges, as you know from the world. Of course, some of them have actually collapsed, as you know, just a few months ago in the FTX kind of the situation itself. And so crypto exchanges are actually a big part of the ecosystem as well, because why? They actually onboard a lot people like me and you into the different ecosystems of blockchain. So you have different coins, allows you to buy the different coins, allows you to send out. And a lot of these are, we are not at the stage where we need we have a decentralized exchange yet. Yeah. So all these are mostly managed by a middleman, in fact. Yeah. And so then we go on to the wallets in the Tezos ecosystem itself. We do have two have prominent ones. There's a lot more actually, but I will only go through two of them. So the Tezos, there's this thing called the Temple wallet itself, and there's a Kukai wallet. So what does a wallet does is that when you create a wallet, it allows you to hold your crypto coins inside on the wallet itself, as well as other have items such as NFTs and other coins as well. So it helps. So it's in most of the coins would have all these kind of things. It's either it could be on Ethereum, it's going to be on MetaMask, on Tezos, it's going to be on the Temple app itself. Yeah. And then you come on to this part where, of course, you have this thing called the hardware wallets, where you want to be a bit more secure, because if you actually install a Temple wallet, it's not exactly the safest option to do it, because most of your keys are stored online, you see. So now with this, it helps me. Hardware for wallets helps you to make things a bit more secure, I would say. Yeah. Then these are some of the aggregators that you can look to. Yeah, and a bit more about on the DeFi part actually. So the DeFi part as well is if you a lot of people what they actually do on all these on the crypto on the currencies is actually they want to build a new financial system itself. So a lot of people what they do here is that they want to build have lending protocols, have decentralized exchanges, more things to do with options and trading. A lot of these are mostly towards a new kind of financial market. So a lot of these are actually good use cases to make sure that there is no a middleman to actually work with, because as you know, a middleman always takes a lot of your fees out, and he charges a very high fee for his service. Yeah, so this allows you to build all these kind of things, and it will be a cheaper way to do either a business or in finance as well. So this is just an example of a decentralized exchange where you can use it to swap coins around, you can use it to stake pools around. So all these are being done on the Tezos chain itself. And I won't be going through on NFTs because Ho-Chi has went through it already. But some of the examples of where you can find on NFTs on the Tezos ecosystem itself is on object.com and Kalamin and FXhash. Yeah. So then this is more towards the overview of what the ecosystem can be on the Tezos chain itself. So first thing, you have the tools and your wallets. So that's how you want to create your smart contracts, your wallets, your D app as well. So that's going to be your first part as a developer itself. And then we also have the DeFi part, which allows you to to create new applications, new protocols, have new coins around for different use cases. And then we also have on the NFT part, which is mostly the projects and the marketplaces as well. And we also got D apps around, which it can be used as you can be used as a way to fundraise it's for money and things like that. So it's going to be a lot of different things that you can hope to actually work on in in the Tezos ecosystem itself. And we also work with different corporate entities such as Ubisoft and Red Bull as well. So these are the different things that we also do on the Tezos chain itself. And you can always find us on Discord, on Telegram. We do have developer groups around, that helps to answer some of your questions on, how you want to build on your own app and things like that. They will help to answer some of your questions. We do have a GitHub and GitLab community as well. Yeah. And so then we come on to the Blockchain Explorer. So what is a Blockchain Explorer? It's where you go to a Blockchain Explorer and you can find your address. You can find the transactions. You can find the blocks. You can find all it's a transparent way to see what is going on in the blockchain itself. Yeah. I mean, I'll just show you a bit more of a demo at the very end. Then it's a very short demo. Then it will show you what are the transactions being done, etc., etc. Yeah, so these are some of the developer resources that we also have. You can go to Open Tezos to look for more, have answers if you want to know more about Tezos itself. Yeah. And we also do a lot of projects, a lot of grants. So we have the different projects and entities around. It can be in the university, it can be a startup, it can be in my student groups here as well, where we help out. I help them to understand a bit more towards what is the blockchain about, and we also do a lot of workshops for a different for universities across the space. So I work with NUS as well to do on their collaboration for their college students as well here. Yeah, so we do promote the use case of blockchain and education on that as well. Yeah, so then we come on, okay, then like the whole thing about for Web3, if you ever heard about this or crypto or Web3, there's a lot of names for it. What is Web3 about? And what is Web3 is you can go on to the very start of the history of the internet. So for Web1, as you know, it's like your mosaic, it's like your Netscape, where you have this kind of static kind of the websites that it has very zero interaction with the users. You go there, you just need to read things on the website itself. And at the time, it was a very very early stage of the internet, where you just build things in information or text or image kind of stage. And then of course, when we come on to the late 2000s, that will be like the era of your Facebook, your Instagram, your all your big tech things like Facebook, Instagram, and Twitter. And this is a time where a lot of these apps are controlled by the big few on big few companies itself. They also charge a very high rate of fees as well, just for you to use in their creation process. And now the new Web3 is where, since the invention of Bitcoin, and since since this last 5 to 6 years, in fact, I think there has been a rising and a growing need for decentralized applications to replace mostly your centralized on your platform, and to make sure that fees are in one sense kept low, and to make sure that its for power has been given to the users as well. So it helps to spur like a bit more growth with different communities around the world. So you can actually use all this kind of Web3 or blockchain technology to help to connect with different people all across the world, and to help them to run on their own, have a protocol as well, I would say. Yeah, and some of why it's so important is that, firstly, is decentralized. You own the whole thing. You actually own your coins. It's not by a bank. It's not by a central party that owns your NFTs, your coins and stuff. It's like that. And it's also permission, where you cannot be censored in the internet. But if you want to go to Facebook, they can ban you if they want to ban you. You see, when you go to a Web3 or a crypto kind of application, they cannot ban you and things like that. So it's very hard to for them to do all these kind of things. And yeah, you also have your own trustless kind of a function, where it helps you to operate in a certain way, but it's trying to use incentives and economic mechanism instead of relying on a third party to do it for you. So that's the main part of the Web3 kind of the space around. And yeah, so I think that's almost the end of it. But so what we do here at the in Tezos itself, we actually help to award grants to help have companies or groups of people to build applications using the Tezos smart contract itself. We also help to conduct educational workshops and also help to bring forward new and different projects around in the ecosystem itself. So if you read more about us, we do a lot of these kind of initiatives to help anyone in general to help to promote on the blockchain kind of space. Yeah. Okay. I will just do a short demo of the blockchain explorer, and then I will pass on to Atalia actually. So a bit more on how on the blockchain explorer works is that you can actually see that this is a current on the cycle. This is the next block that is going to be the case in 20 seconds. Then the next block would be coming out, and the bakers are the one who actually verify and validate on that. And then you also can see that, as what I said, there's going to be 5 on the stages where you boot and you process all the amendment or all the protocols and the periods here. This is the governance part. And this is also on the staking, where I said that, you want to be a baker, a staker, you can participate in the network. So you can see there's about 76% of all the Tezos being staked. Means that there's a lot of people actually trying to participate in the network itself. And you can actually see that these are the like active accounts and some of the rest of the stats here, and smart contracts as well. So if you look at all these are the different blocks, and the different have dApps itself. You can actually see that what are people trying to use. Some of these are the users, the interactions, and etc. etc. This is the price. Yeah, so it's a good way to explore around, see how it works. In the hash, the block, the hash function, and some of the transactions being have taken place. So transactions are things like, oh, I want to buy a certain item from a marketplace itself. So you can see, this is a user has bought an NFT from a marketplace itself. It costs him how much? Yeah, and etc. etc. You can actually see a lot of this kind of stats around on the Explorer itself. Yeah, it's more for you to explore as well. Yeah. Okay. Yeah. So I think I've come to the end of it. So before I end, any more questions? I'm gonna do a poll again to see how to launch on the next part. So I'm just gonna launch on the poll. You can just do it actually. Yeah. I cannot launch the poll. I think it's fine. Okay. I think you can take over it actually. Yeah.
Thanks also Hochi, for the explanation about the blockchain. Yeah. So any of the student want to pose some questions? Maybe I want to ask some questions. Like the people always think that the blockchain actually ensure the privacy, right? Because of the anonymity. In a sense, it's quite good for case whereby you actually want the to be ensure the privacy, right? But on the other hand, actually it use a lot of time for the money laundering. How do you actually handle such situations whereby I think actually the transaction of the cryptocurrency actually it cannot be tracked because of this anonymity. Yeah.
Okay. I think to answer on that question, I think so on a blockchain, all transactions are public actually. You can actually track which address that like let's say you want to send a Bitcoin from A to B, and each address is actually tagged. So if you think about it, you can actually track if someone stole or money laundered through an address. You can actually track the address and track where he actually sends it to. while it's not a foolproof way to say that, you know, you can't check the identity, but it's really very hard because, you know, you want to sell a Bitcoin, right? You still need to sell to someone. Yeah. And if you sell it onto someone, it's going to be either an exchange or a peer-to-peer kind of a thing where you need to give it over to someone. So exchanges do have that kind of a regulatory aspect where they need to know on your customer. So I think it's called the KYC kind of thing, where they need to know your address as well. Yeah. So before, if you ever send the money laundered have Bitcoin to exchange, they will probably know who you are as well. Yeah. Yeah. If that answers on your question, yeah. Okay.
Related to the survey that being posted, right? I think seems like assuming that the audience come from the professional background. I think here is the mostly student, I guess. Yeah. So you ask what are your project team you belong and so on and so forth. Yeah. Yeah, I think it's for Atalia actually. Yeah.
Yeah, I mean, we do have a survey, minta tolong buat diisi, just so that we get any feedback kalau misalnya what we can improve on and apa namanya for our workshops, and I want to know if kalian mau belajar mengenai Tezos lebih lanjut lagi, we can definitely do apa namanya workshops or activities in the future. And if you have any further questions, sebenarnya since emang udah jam 5 ya, jadi you can post it di Twitter. Kita juga ada Twitter for Tezos IDN, bisa ditaruh di sana, and then we'll answer all your questions juga. So kalau dari nggak ada pertanyaan lagi, go ahead.
So yeah, I think if Ho Chi, you want to share your own experience in what we actually did in our hackathon, since most of the people here are students actually, right? So, you know, if they want to, so actually each year we also do like hackathons and barriers for other mini hack competitions. So I think Ho Chi here has participated in a few hackathons by Tezos itself, and he has won quite a lot of prizes in the past as well. So what were your experience? Ho Chi?
Actually, I just participated in 2, and I won runner-up for one of the categories in the second one. So for the hackathons, it's actually if you are interested, it's international, I think. Yeah, because there were participants from Singapore, there are participants from India as well. I think it's open to anyone, any students. You all can go and sign up. I'm not sure when they will hold this year's one. That one you have to ask Bryan. But from my experience, there were workshops provided throughout the hackathons, which I attended a few, as well as the hackathon lasts around 1 month or to 2 months. So you have a lot of time to design, prepare, and build your stuff on the blockchain. So that's from what I can see, you can build basically anything. I've seen from the presentations given by other people, there are the apps, games. For me, I built a website which mints NFTs. Then there's a WhatsApp bot, Telegram bots. The WhatsApp bot actually won one of the bigger prizes, and the prizes they give is very generous. The WhatsApp bot won $15,000 US. So if you're interested and want to learn something with a chance to win some money, find some friends and come and build something with in one of the hackathons. Yeah. is what I was saying, I guess. Yeah.
Thank you. Kalau misalnya udah, berarti thank you semua everyone for joining. Thank you banget buat Kalbis Institute for this opportunity. I hope it's fruitful dan semua orang bisa belajar sesuatu yang baru dari workshop kami. Kalau misalnya ada questions or you want to know more, aku udah post juga, kita ada di twitter.com /Tezos IDN. You can ask more questions, and we'll follow up with you and do the best we can buat ngejawab semuanya. Kalau gitu, aku tutup dulu untuk workshop hari ini. Thank you banget semuanya and have a great weekend ya.
Thank you so much for all your time. Yeah, and thank you so much, Prof. Edwin, for actually hosting this as well. Yeah, and I see you guys soon. Have a nice day.
Yeah, thanks, Hochi and Bryan. Yeah, have a nice weekend and stay safe. Yeah.
Thank you.